This podcast is brought to you by Infrastructure Masons, uniting builders for the digital future. Looking to turn your innovative idea into the next big thing in digital infrastructure? The iMasons Incubator is here to help you connect with industry leaders, spark awareness, and accelerate your path to success. If your concept can help drive a more sustainable digital future, we want to hear from you. Don't miss this chance to grow, give back, and shape the digital landscape. Email innovation@imasons.org today and find out how the iMasons Incubator can help bring your idea to the world.
Dive into the world of data center innovation with the iMasons podcast, discovering the people leading the industry revolution. My name is Roman Truncheon, and today I'm joined by Lars Ficker, Operations Director at the data center section of SES, a national design and build contractor, part of the Wates group. He has agreed to take us through the practical aspects of designing, building, and commissioning liquid-cooled data centers. We will talk through the pitfalls and the changes that are required to continue operating high resiliency environments. Let's get right into it. Hi, Lawrence. How are you today?
I'm fine. Thanks very much, Roman. Good afternoon.
Well, thanks very much for coming on a podcast. You're a long-time member of iMasons, if my memory is good.
Yeah, I think it's a very, very good organization to have in the industry.
Yeah, we're always very happy to feature long-term members on this podcast, and actually we're very grateful that you've accepted to actually come and talk to us today about your what you do on a day-to-day basis, which is design, build, and commission liquid-cooled data centers. And so before we get started into this, can you give us a bit more background around what you do, where you work, the sort of projects you've undertaken? And then we'll get into our questions.
Sure. So the Wates group consists of construction businesses and MEP services businesses, as well as FM and things like that, and specialist fit out. So they actually operate across the whole spectrum of sectors and not just data centers. However, Wates have a track record with clients such as Segro, building data center facilities. My own background is probably coming up 9 years of working in the data center sector specifically, always in the design and build contracting side of that industry, sometimes as an MEP subcontractor, sometimes as turnkey GC solution.
That's fantastic, and right on point with all the line of questions that we've got for you today. Let's get started with an easy one, right? So for design and building, what do you think are the biggest challenges about delivering direct to chip liquid cooling data center designs?
I'm glad you started with the easy one. That is, I think, a big challenge for the contracting businesses, and particularly the design and build aspect, where we are often asked to take full liability for the design being correct, suitable, and meeting all of the ERs. The extent to which the types and of servers being deployed right down to the individual manufacturer makes such a difference now to how the data hall critical cooling has to operate, that it's no longer possible for designers to create a sort of vanilla or generic solution based purely on your standard IT load. The nature of the servers and the way in which they need to be cooled is very specific to manufacturers. That means that without the knowledge of some very specific information of the servers that are going to be deployed, it's not possible to say categorically that all of your critical cooling and indeed your power infrastructure is entirely optimized and adequate. And that can then lead to the choice of you either defer some of those choices until something's known, or potentially you you have an excess of capacity to create some flexibility in terms of what can be deployed in the hall, but you'll certainly not be able to necessarily adequately price for the installation and commissioning of something that you don't know about, but does intrinsically impact upon the completion of the installation, the testing and the validation. That becomes really difficult to do.
It's interesting that you mention all of this, and we'll definitely come back on differing choices down the line based on what you already know of your IT servers. I think there is a lot to unpack there. But what it feels to me, based on what you're saying, is that in reality, the process is getting reversed based on what we had before, where the 19-inch racks, air-cooled, was very much the standard. The only thing that mattered is how many kilowatts are you going to have in there so that you can size up your PDUs and make sure you had enough cooling. But in reality, the data center was the last thing you would think about, because your IT equipment would fit in and just works. But correct me if I'm wrong. What you're really saying is that now the whole thing is reversed. You almost need to start, or at least engage with the data center at the very beginning of your project, just to make sure everything is aligned. Otherwise, you are overpaying, or you might not have the right solution.
Yes. I mean, you just could be selecting plant and equipment with operational temperature ranges that don't fit with the requirements of the server manufacturers, which are quite prescriptive. And because the way in which one manufacturer's direct-to-chip server is laid out and piped up is different to another one. So there's a different temperature gradient flow through different servers. So clients, particularly co-location clients and developers that are looking to offer the facility to a variety of tenants and users, they need to try and map out for themselves the validity of what they're paying for, and what are they getting in for their money in terms of how marketable is it if you are a colo, without knowing. And I think that will probably lead to some strong alignments between the individual server manufacturers, the end users deploying those servers, and the colo people that are providing space for them. There can be flexibility around footprint and moving items from one facility to another, but to all intents and purposes, the most optimized design is going to be based on a particular server. And that's very different from an air-cooled solution.
That's very interesting. We'll make a bit of an assumption. We'll assume somebody came to you with every information you needed to actually provide the right design. You've gone through the constructions. Now come the time of testing that the solution actually works before the IT goes in. Can you take us through what it looks like in liquid cooling, maybe challenges that you're facing? Things are different because we're operating in a liquid cool environment.
Yeah, sure. Yeah, the biggest difference is that the final cooling circuitry may well be part of your, and is probably going to be part of your tenant end user deployment. Air-cooled hall, critical power could be tested right up to a level 5 IST, including resilience. And the hall could be proven to the extent that the fit out works. The fit out specialists were basically, an IT. It was an IT scope, and they knew that the critical cooling and the critical power had been completely validated. Now, without having that final circuitry, and the practical issues around creating a temporary load in a liquid media compared to say rack-mounted emulators in an air hall, means that it's not possible to get to that same level of complete validation as part of a base build before a tenant fit out occurs. That possibly means that there's a need to consider the commissioning differently and commission components to a certain level, maybe in a more detailed way in a fat test environment, say your CDUs, because finally you will have 4 CDUs, but they will be piped up to a certain server manufacturer's equipment. None of that pipework is going to be there at the end of the base build construction. So even if you try to replicate it and then remove it, you are removing something that is an intrinsic impact on the function of that cooling. And therefore, what is the point in wasting time and money installing it temporarily, testing it in a fake manner, and then taking it back out? So I think we'll possibly see a demarcation point where there is a requirement in the fit out for some revalidation or validation in the first instance of those final cooling circuits, and that'll shift into being part of that final fit out scope of works.
Do we need to start looking at commissioning in a slightly different angle, in a way that in reality you're no longer commissioning the plant, you're commissioning an entire system, which means the commissioning continues even when the IT equipment is actually being installed in the hall?
I think that the fact is the system has now got a split installation scope, and whilst you can put a temporary large load from some hired-in containerized heating plant to prove the main chiller plant, your main distribution, and the resilience and control function of those, you can't take that to the nth degree once you get to the edge of the hull. So now it needs to be done as part of the whole fit out until such time as there may be some higher equipment, for example, that provides that liquid heating. Because at the moment, the largest skid mounted hired in plant that I could hire is a 500 kilowatt unit. Most CDUs will be comfortably 800 kilowatt. So now I need 2 of those, which are, they're too big to take up in a goods lift. A 2 megawatt plant containerized will be in a 20-foot steel container store. So it's not, there's a real limitation on how we would even provide a temporary heat load into a liquid media in an individual hall space.
I mean, we pride very much ourselves on that, on the level of testing, resiliency of the infrastructure. This is literally what data centers are here to provide, the level of resiliency. What are the things that we need to do as the environment is changing to then gain back the level of confidence that users, customers are used to have in the fact that those facilities were installed as per requirements?
I think that's one of the biggest challenges, is without giving $4 or $5 million worth of actual operational servers up for inclusion in part of the on-site empirical testing and potentially damaging those. How do you recreate that final deployment artificially? And I think it's going to come down to some more detailed and possibly externally certified testing in an offsite environment of the CDU function and even the server cooling distribution inside server racks. That's with, and so you'll get, if you like, a certified amount of componentry to incorporate into a final design, rather than being able to carry out a level 1 to 5 testing validation regime on site. But you can still do all of your critical cooling plant, all of your critical comms and controls for that cooling plant and and any generation. It's within that white space that I think, clients particularly need to be aware of the difference in what can be commissioned, what can be validated and proven. And most contract ERs are written such that we would need to prove empirically on site that the actual installation fully complies with the ERs in terms of capacity and resilience and functionality. If the final cooling circuitry is no longer there, I'm not able to do that at the moment.
It's interesting because based on everything you've said, what it calls for, what it seems to call for is a reset of the expectations of the end user of those spaces. But also attached to this, a much more formal integration of what you and your firm does, as much as the IT equipment provider, as much as the end user, so that there is a true not only alignment but test procedures that goes and carries on all the way through. It's no longer compartmentalized. It's actually coming through as one big system that now needs to work in unison. But we've never really had before to test it as a one big group, right? Do you see this shift at the moment in how those integrations are happening? Do you see contracts being written differently in a way that carries out for this?
Not at the moment, because it seems to be so new. Since I started reaching out to people at the middle of last year, people are really concentrating on the impact to them as a manufacturer, for example, and trying to keep up with what are the various permutations of liquid cooling solutions. How do they operate differently? In terms of their design criteria, their functional criteria. Who is looking to adopt which version? Now, there's been such a lot of various learning curves for everyone. Pulling that together into, okay, so we now know what we want. How are we delivering it? And what is what does the contractual vehicle look like that, and terms and conditions? That's all still really feels like really unfirm ground. And I think that would clients will have a choice of contracting to the point where the contractor says, I'm just going to build what you've told me, and I'll put pipes through the end of the wall with valves on, and I don't have any ownership of what's after that. I don't think that's really going to serve anyone, even the contractors, because you're unlikely to not be called back to partake in dialogue around the design. What did you install and what can it do? Whereas the smart integration, I think, is going to make a more joined up process of the original design and build contractors and the clients sitting down and assisting the formulation of that fit out scope, which includes an element of final validation, revalidation, whatever you want to regard it as, but with the attendance of, say, the base build contractor. And that's a bit of a leap of faith for the contracting industry, where we like clean demarcation, and we don't like being involved and overlap, because it could be, did that go wrong there, or that there, or but I don't think you can really justifiably say you're looking after a client's interests unless you can say, we might not be able to price the physical elements of this installation, but what we can do is work with you to work out what you'd actually require and when you require it. And because I think that will also inform the client. They might well be able to go away and make certain decisions and incorporate those into the, to validate elements of the design if they were aware quite how vital it is to come up with a thorough commission and validation package, for example. So yeah, I think we've got to accept that overlap, and we've got to get a bit more shoulder to shoulder to make these first deployments work.
Yeah, it's prone to change for sure. What we tend to see and what we tend to hear is that, when we talk about liquid cooling, we always envisage a full-blown data center, liquid cooled, nothing else, just that as one aspect. You and I have talked about it in preparation for the podcast. It's just not the case, and people want flexibility, and they don't have all the information on hand when they start doing MEP evaluations and different aspects of it. So, is there any ways that you've seen or proposed to clients, which are still valid, in which you can have the shell and the core maybe designed in different ways so that we can keep the level of flexibility without blowing off the budget from the outset?
Yeah, I think that the budgetary concern would be the major factor. The bottom line is we are creating cooling capacity and power stream distribution, and it's not that difficult to come up with two different operating functions in terms of like cooling temperatures and flow rates and that. But you then need to cater for both of those solutions in your major plant and in your distribution system. So you could well have additional chiller plant, additional plate exchangers, so that you can shift capacity from one system to the other. So that if, for example, as you spoke about earlier, if there is a hall with 100% notional capacity, but the client needs the flexibility to gradually transition from an 80% air, 20% liquid cooling to 80% liquid cooling and 20% air, that can only really be done, without shutting the facility down and making physical changes again. But that can only really be done by the inclusion of additional plant and controls to allow that apportioning of cooling at the right operating conditions to be shifted from the chiller plant. And then that does sometimes mean that you've got to consider, have we impacted upon our resilience? If you're doing that and you've got one plate exchanger and that plate exchanger fails, you've got a single point of failure. So I think we've got to be careful in that scenario that in creating the flexibility amongst that additional complexity, we don't create single points of failure, and we don't affect the resilience of the plant. So it can be done, but there is going to be, in most cases, some element of additional cost.
We also talked about the fact that a measure like PUE, and bear in mind that we've had a number of discussions around the relevance of PUE now in the new age of liquid cooled data centers. You were basically saying, well, look, if you want a flexibility, you need to over provision. If you need to over provision, you're going to need to consume more power to actually cool either air or liquids. So therefore, all the efforts and drive we've had in improving the efficiency of our data centers are going to be outdone by the need for flexibility. And basically, there is no other way around it.
Yeah, I think certainly, cooling liquid media is a more efficient way of removing heat. There's no two ways about that. Where we've got the hybrid scenario of a mixture of air and liquid, and flexibility in that hybrid scenario, you've got potentially the additional plant. You've got a greater proportion of or value of embodied carbon in your original build, and you'll have system losses. You'll have additional power requirements in theory that, depending how, and people have come up with some very creative ways of calculating their PUE, but depending how you calculate that PUE, arguably this next phase is going to reset operational PUE back up to where it was, say, 5 years ago. And part of that is what I have seen in some dialogue is server manufacturers looking to achieve extra resilience in the cooling circuitry by operating at an artificially lowered temperature. Not that their servers can't operate at the higher temperature, but because they've got a shorter time to failure if there is any interruption in the cooling, they want to create that resilience by the server chipset running lower than, giving themselves a buffer in that operating condition. So then again, we are then, having spent the last 5-10 years trying to drive up operating temperatures within the server hall, we're then back to a situation where we're overcooling out of caution about resilience. And again, you can understand it. the value of those servers, if they get damaged, is now, as in an AI environment, is obviously many factors more than it was.
Yeah, for sure. What an interesting conversations, and I know a lot of people would love to pick that up with you. Probably have to bring their own experience as well. Unfortunately, this is all we've got the time for today. But a couple of things for all of our listeners. Lawrence is actually accessible through the iMasons app, so I'm just going to put the link here on the screen. If you're listening to us, imasons.mobilize.io, which is the internal applications. Also, come and have a look at the innovations page on the imasons.org website. You'll see in there a number of the activities that that we're undertaking as the innovation committee. And final word, first of all, Lawrence, thank you for coming in and explaining all of this. That has been incredibly insightful. I hope many people reach out to better understand that topic, because this is something that I believe is really under talked about and should be brought at the forefront a lot more. And on that note, again, thank everybody for coming and listening to the podcast, and Lawrence once more for coming and talking to us. Thank you.
Great to speak to you. Thanks for your time.
Take care.
1, 2, 3, 4.
Infrastructure Masons is a global, non-profit, professional association of individuals connected and empowered to build a greater digital future for all. If you too want access to networking events, forums, and summits that foster innovation and influence, register now and join the other 6,000 committed participants at imasons.org/membership application.